Hey everybody, welcome to the CS10 midterm review session on fractals. So yeah, we'll be going over some general midterm advice, a mini lecture, and some tips on fractals, doing a quick demo and practice problems. Um, yeah, so before the midterm, uh, when I was a student, I found it helpful to kind of review and organize your notes so that you can save time during the midterm. I know the midterm is, I believe, maybe 1 or 2 days take home midterm, but it's easier to kind of organize your notes ahead of time, uh, just to make the midterm easier to take if you have everything organized before you take it. Um, I guess make some crib sheets on concepts you feel least comfortable about, um, walk through and take note of exam problems you find difficult, figure out why you might get those wrong. Uh, Use these when you try to tackle similar problems. Definitely go to office hours if you and definitely you can ask questions about past exams and we'll be happy to help you there too. During the midterm, there's going to be problems of varying difficulty, right? And if you find a problem hard, you can go back to it later after you've had some thought on that. And definitely take breaks in between and get some rest before the midterm and eat well also. And yeah, like treat yourself once you finished also. Okay, so fractal advice. Do you wanna okay, so I guess going a little bit forward, this is kind of like what a fractal problem will look like on a midterm exam, right? So we have four cases, right? And we have the base case n equals one. And this one is just a straight line. We usually start pointing in the direction 90 degrees. Um, Okay, so essentially, we look at the base case, n equals one, and we kind of compare that against level two. And we want to circle how many instances of level one occur in level two, right? And in this case, level one is like the bolded lines right here. So this is a recursive call right here, and this is also a recursive call right here. So, or just to make sure we're on the same page. Uh, so these two are the recursive calls right here. This is not a recursive call. This is length of this is length 1/3. Um, this is length 2/3. These two are of length 1/3, right? Um, clear that. Clear drawings. Okay. Right. So okay, once we find out so we see that there are two instances of like the golden lines, right? So those are essentially the number of calls that we make in the else case or in the recursive case, right? Um, and once we've figured out how many recursive calls we have, everything else is the work that we're doing inside of the like recursive case, I guess. I guess in other words, it's like this n equals two. The additional amount of work outside of the recursive calls is, I guess, move 1/3, uh, move 1/3, remove five steps or size divided by three steps. Sorry, right here, and then we would have to turn 90 degrees to the left, right? And this is the recursive call, right? And once we're done with the recursive call, it looks like we will have to turn 45 degrees to the right. And this is not a recursive call. This is additional work that we're adding in the recursive case. Um, this is moving 2 times 3, or size divided by 3 times 2 steps right here. And then we turn, it looks like um, that looks like 90 degrees to the right. Um, I hope I'm right about that. But and then once we've done that, um, this is the next recursive call, and that's essentially it. But then we need to make sure that uh we face like direction 90 degrees when we finished, I guess. In this case, I believe, yeah, it says it ends in the position the sprite is in the picture. So the sprite Alonso right here is facing the 90-degree direction. Um Yeah, so just to reiterate, we figure out the number of recursive calls. We find the work that's not done, that is not part of the base case. Um, Once we finish that, we need to make sure that we face the correct direction after each recursive call and the base case too. So in every recursive call, we usually decrease the size depending on what the problem says, and we must decrease the level by one at each recursive call. And I guess the way I do this, I like to kind of debug as I go. So I would work starting at n equals one, make sure the base case is working correctly. And then I guess at n equals two, I would kind of do it one step at a time, kind of edit live, run the script live as I'm doing each step. So the way I do it is I would start with this part of the n equals two case. Um, and then I would run the block to see like does this match the picture so far, and then I would create the recursive case, make sure does this match what the picture looks like so far. So instead of just kind of writing all the code out for the whole n equals two case and then trying to debug, that's a bit harder than trying to then just like kind of checking um, each each part at a time is easier to debug. So essentially, uh, kind of make uh, debug as you go and just double check your work after each line of code you write, essentially, is my suggestion. Um, right, okay. So these are like the most helpful blocks when kind of creating your fractals. Um, I guess moving steps and then kind of backtracking is like pretty common, like move minus size steps. This one is important for like the well, I guess like move size divided by three times two steps. You would have to do something like this. Um, yeah, the move steps, the turning left and right degrees is really important. And this kind of block of code essentially kind of clears the stage when you're kind of debugging or testing your code. Go to X, Y, 0, 0 is kind of like the origin of our kind of like graph and snap, which is the center of our graph, right? And clear kind of clears like any pen uh drawings, right? And pen down means like everything that you draw after the pen down is going to be displayed on your snap um program. And pointing direction 90 degrees, that's usually it, usually that's what it is, which kind of faces to the right. um but it depends on what the problem like kind of specifies. You're not always going to point in 90 degrees. And then that's when we have like our fractal block that we test out. So this is kind of like I'll show you guys an example too of what I mean by this, but this is kind of the general like flow of how we want to run our block. Um, yeah, so also don't use point in direction for your recursive cases because like okay, it might work for like n equals two, but your code will probably end up breaking for n equals three, n equals four. So inside of your actual fractal block that you code up, don't use point in direction. It will not help you. Um, Oh yeah, you should always utilize turn degrees, not pointing direction, because it doesn't work in terms of the recursion for n equals three, n equals four. So okay, how would we do? Um, so here's like a fractal from discussion, right? And so the first thing, yeah, so first we wanna when I'm coding this up, I'm gonna start with n equals one, look straight to that picture and write out the base case, right? And so we're pointing in direction 90 degrees, which is just gonna be assumed. We're not gonna like put that in our block. We're gonna assume that we start at 90 degrees and we end at 90 degrees, pointing in the direction of 90 degrees, right? And so at n equals one, all we're doing, uh, well, n is the level, right? And so in this case right here, right? And so at level equals one, all we're doing is moving side steps. So that's the base case, right? The base case is in the if statement usually. The else is the recursive case, right? Or we're going to code up our else case looking at n equals two as kind of our guideline. N equals three, n equals four. We're not going to utilize that at all in terms of um, maybe we can kind of get the idea, but in order to code up the recursive case, all you need to look at is n equals two, right? So what we need to do is look at the recursive calls. What is bolded, right? So what is bolded is right here, right? And the not everything else that's not bolded is the work we're doing in the else statement, right? At each kind of level in our recursive call, we're doing this amount of work, which is right here and right here, right? Um, yeah, so in terms of any level equals one, uh, the way I do this is kind of like just live test this. This would be my script. This is my fractal at level one and size 200. Draws a straight line. It looks like we're good, right? And so let's see how we're going to do the recursive case, right? And so we see that there are at, at level one, so the amount of instances we see in level two of level one is like what's circled in red, right? So those are our recursive cases, right? And now, okay, now actually coding it up, we we see, I guess, going back to n equals two. This is moving one third of like the inputted size, right? I guess right here. So this is one third, right? This is also one third right here, the recursive call. This is two thirds, and this is one third, right? And cool. So that's the first thing we're doing is moving size divided by three steps, right? And now what we need to do, so like remember like we point in direction 90 degrees like this way, right? And now we need to kind of once we're done, our sprite is going to be facing let's annotate actually. Um So our sprite is going to be facing this way, 90 degrees when we're finished, right? Uh, but what we actually need to do is we need to turn to the left 90 degrees in order before we do our recursive call, right? So we need to be facing this way right before our recursive call, right? Um, so that's what we're going to do. See if that's what I put next. Uh, Right. Okay. So we turn left 90 degrees, and then we make our recursive call, in which our recursive call, which is right here, uh, we're moving size divided by three steps, right? And so that's what we're going to do, kind of decrement the level by one, which allows us to go into the if statement in our recursive, like once we call that, right? And so, yeah, so we're going to input size divided by three, decrement the level by one in order for us to reach the base case, right? If we don't decrease the level by one, we're never going to reach the base case, right? Um, Right. And so I guess the next step after that would be so that's the recursive call. And then what do we do next, right? We need to kind of turn our direction right. It looks like that's we're going to be actually hold up. So we are going to be pointing this direction, but we need to point this direction before we move. So it looks like we need to turn right 45 degrees. That's right. Oh, sorry, 90 degrees. Yeah, 90 degrees. I'm sorry about that. Yeah. 45 degrees would kind of be in the halfway point. But yeah, so we turn right 90 degrees and then we move size divided by three times two steps, essentially, right here. And that allows us to go here. And remember, I'm editing this live, just so it's easier to debug. And we know at each step, like at each step, we can see if we're correct or not. So it's easier to kind of code it up live like this to see if we're matching the picture rather than trying to code everything at once and trying to debug like that. Um, so okay, now what do we need to do after that? We need to, in order to match the picture, we need to turn 90 degrees to the right before we make our recursive call, right? And our recursive call is kind of the same deal where we move size divided by 3 steps and decrement our level by 1, right? And okay, now we're right here. And the last thing we need to do is we need to point in the direction that is indicated in the picture, which I believe we would have to uh, turn right 90 degrees. Or sorry, turn, yeah, I believe, or technically I believe that's a left, but yeah, turn left. I get kind of confused sometimes. So yeah, it's easy to just use snap or kind of see it intuitively. But I guess in this case we would need to turn this way in order to be pointing in the direction 90 degrees. So it looks like we're um, yeah, we kind of like use hand waving motions to kind of see which way we want to go. But yeah, we want our sprite to kind of be turning right, I believe. Yeah. Cool. So that's kind of the end of n equals 2, right? And once we finished n equals 2, um, n equals 3 and n equals 4 should work just by recursion. We kind of take the recursive leap of faith. We assume our code works. If it works for n equals 2 and n equals 1, we assume it works for n equals 3 as long as we kind of have like our turns correctly, the right size amount of steps inputted, and that we are reaching the base case somehow. So we take the recursive leap of faith and assume it works for n equals 3, n equals 4 for any integer n greater than 2. And if we don't utilize turn and we try to use pointing direction, um, you're like when I try to do it, this is what it ended up like. So for n equals 3, it looked like this. So we do not want to use pointing direction. We should utilize the turn block instead. And make sure you check your work during the exam. Then and make sure that it works for all levels. Um, yeah, so make sure you decrease your size at each recursive call. Your fractals should always take up the same amount of space on the screen, and don't use the face direction block. Cool. So this is just a meme, but you want to use turn block. Don't use your point and direction block. Cool. So I guess practice questions. I think I'll do fall 2018 another video, but I guess we can kind of try this one live right now with the audience. So okay, actually let's have it open like this. Okay, so this I don't know if this is from a past exam or not. Um, but here it is, right? So n equals 1. We're going to look at the base case. We're going to code that up first. So here is kind of like my clear pointing direction 90 degrees. And here's my fractal, which actually does nothing right now. But we have a size, a variable size, and we have a variable level, right? And so we want to move size amount of steps. We're assuming that we're pointing in the direction 90 degrees. We want to move size steps, right? And then what are we doing after that? We want to turn left 90 degrees. And let's kind of do that right now. So we know we're going to want an if statement and an else statement. The if statement is our base case. If our level equals 1, right? If our level equals 1, all we're going to do the base case, right? And so we're moving size steps, and then we're turning 90 degrees to the right. Okay, so once we do that, we're moving size steps again, right? And we want to just double check where's our sprite kind of pointing when we finish this, and it's pointing in the same direction. It's pointing in 0 degrees, right? Kind of like it's pointing this direction. So we don't have to do anything after that. And so kind of let's test this out live, see if we're on the kind of the same page. and see if we, yeah, so that is correct. That's what the picture, we can kind of just move this, that the picture produces the correct output, right? For n equals one, right? Level equals one. And now let's go into the recursive case. Recursive case, we should just look at n equals two, right? Don't worry about n equals three, n equals four. Uh, so we know that okay, we're gonna be starting kind of at the bottom right here, right? But we wanna so we know that we have this kind of like function that can output, can kind of draw then n equals one case, right? But assuming that we're starting from like the bottom right here, we want to get into a position such that we can draw like this. Um, so essentially we need to in order for us to draw this at this position, I mean, right now, if we were to like recursively call where we're at, we would just be doing, sorry, that's not straight, but that's what it would look like right now. But what we want to do is actually, how do I erase? Uh, hmm, draw. Okay, let's pause. Yeah, so we start pointing in this direction, right? 90 degrees. Sorry, like we pointed 9 degrees. We need to essentially, wow, okay. Uh we need we need to go up here, which is kind of turning left 90 degrees, moving size. It looks like we're moving size steps. Uh and then we need to kind of rotate 180 degrees, right? And it looks like we're making our recursive call uh right here. Yeah. I guess if you kind of rotate your head this way, and you can kind of see um right here that this is we're drawing n equals one right here. And we're ending up like the sprite would be facing this way when we're finished. So I guess that, yeah, that might seem a little hand wavy, but um let's try to kind of code that up. So we're going to be facing let me take this out for a sec. So this is our starting position, right? And we want to, in order for first we like in order for us to draw like this part, we need to go up here. And so that requires us to kind of turn 90 degrees in the right direction, right? So that's, we're gonna want to have that here, right? And now we want to go like upstairs right here, and we want to move size steps. Okay, so move size steps. And now what does this look like? Actually, we can kind of put level equals two. And what do we have so far? So now we're right here, and now we need to turn 180 degrees uh, in order for us to go in the other direction. So I guess turn 180 degrees once we move size steps. And now we're right here, right? And now the whole bolded line right here is our recursive case, right? And so we're going to put our recursive call next, which is going to be right here. And we're going to decrement our level by one. And we're going to, looks like the size is the same. Actually, is it the same? Uh, I don't know. Give me a second. It looks like it's size divided by three. In the exam, it would be actually be more clear as to what the size is supposed to be. We'll specify that. I'm gonna assume it's size divided by three, but actually let me double check. It's actually size divided by two, but we'll specify that on the exam what um it's supposed to be. Uh, Cool. So let's test this out and see if it matches. Uh, what does that mean? Uh, oh wow. Oh, I think yeah. Instead of moving size steps at that part, we should be moving size divided by two steps. I think that's what's wrong. Let's check that. Yeah. Okay. So yes. Okay. Yeah. Since we're making the recursive call, up here, uh, at size divided by two, we need to move up size divided by two, essentially, right here, since I guess this whole part is size divided by two length, right? And so we need to move size divided by two up before we make the recursive call, not size steps. If we move size steps, we'd kind of be up here instead of up here. And so now once we're done with that kind of recursive call, the non-bolded lines is like the work being done per level of the recursion, right? And so, or yeah. Um, so it looks like we're moving size divided by two steps forward. Uh, and then we're turning 90 degrees to the right. Uh, oh, sorry. This is supposed to be 90. Okay, so now then we move size divided by two steps upwards, right? Uh, okay, so let's just check to see if we're correct. It looks like we're doing good. Maybe I should increase this size to like 100. So just so everybody can see. Okay, that looks wonderful. Okay, so now right here we're making another recursive call, right? The bolded lines is the recursion, right? At this part of the kind of tree that we're making. And so we can kind of just drag this. I mean, maybe I could have just copied this uh, without this. So actually, let's see what happens right now. Okay, so we see in the picture we want to end up with our sprite facing like this, right? But our sprite's right here, and so we need to kind of turn in the opposite direction, uh, and kind of like park our vehicle like right there, I guess. Um, okay, so now we need to move size divided by two steps in order for us to get at that point. Um, okay, so now where do we end up? Okay, so now we just need to change our direction now, or turn using the turn block, right? So turn 90 degrees to the right, I believe. Um, cool. So that's n equals 2, I believe. And kind of using our recursive leap of faith, once we've kind of done n equals 1, n equals 2, we should n equals 3 and n equals 4 should work by just by the recursive leap of faith. And it looks like that's working out actually. N equals 4. It looks like the picture. And n equals 5. And on the exam, we're going to ask you n equals 5, which is not on the um not on kind of on like the picture we given you. And that's kind of the test that like, okay, you haven't hard coded this essentially. So that's what n equals 5 looks like. Um awesome. I'm gonna post another video of the fall 2018 midterm and like a separate thing. But essentially kind of to recap, um uh have like a base case and a recursive case, right? The recursive case is kind of is leading to the base case by decrementing level by 1. Uh, kind of use like the pictures as a hint. N equals 1 is always going to be the base case. n equals 2, you can see what the bolded lines are. The bolded lines are the recursion, right? The recursive call, right? And the non-bolded lines is the work being done uh, inside of the else case that's not recursion, right? Um, yeah, that's kind of the main takeaway. And then the n equals 3 and n equals 4, you kind of use the recursive leap of faith, assuming like, or just by just looking at the second picture, you're able to kind of get the results from the third and the fourth picture without like thinking about the third and the fourth picture specifically. And yeah, thank you guys for watching, and I hope this helped.